Now I introducing the next video regarding the next question solutions of 2023. That is the NMR related problems or problems was came in the NET questions. One is that of the 13th NMR problem, another is the numerical problem in the proton NMR spectroscopy, another is that of the activity of the NMR nucleus in different nucleus present in the NMR spectroscopy, and the fourth problem is that of the type of the signals comes in the NMR spectroscopy. Now, before introducing this problem, we go to that of the how the chemical shift can be changes for the different type of the proton, and how the scale can be arises. How can you remind the scale of the different type of protons in the NMR spectroscopy? That is the this figures is taken from Clayton books. That is there are different scale. One is that of the 0.0 to 10.5, and there in the one figure different type of the protons can be represented. Here the saturated CH3, CH2 and CH groups comes in 0.0 to 3.0 delta in ppm, and the saturated CH3 and CH2 and CH next to oxygen come to that of the 3.0 to 4.5 ppm, and next this is the alkene region protons come here, and this is the aromatic region protons, and this is the protons come to that of the for the aldehyde. And now if we see on that of the 13th NMR, there are different the alkane carbon comes in the 0.0 to 50 ppm, and this is the region 100 to 150 ppm. This is the region for that of the aromatic regions, and we know that the 200 is the very important peak for the 13th NMR. The carbonyl is arises, and 50 to 100 ppm the alkyne, and the next to oxygen carbon, next to halide carbon come here. Now we go to that of the cause of the chemical shift. Why the different type of the proton and carbon present in different showing the different chemical shift value in presence of the applied magnetic field. We know that in the NMR spectroscopy, applied magnetic field is applied for the various type of the nucleus, and if we show that of the diamagnetic anisotropic effect, in the case of the diamagnetic anisotropic effect, if we apply the B0 and the magnetic effect is opposes the applied magnetic field, and hence the carbon peripheral carbon for the aromatic carbon present in that of the paramagnetic zones, and hence we get that of the different type of the chemical shift value or different carbon atoms. And if we see that of the carbonyl groups, there are also a diamagnetic anisotropic effect between that of the carbon and the oxygen atoms, and the nucleus fall in that of the paramagnetic zones, and we get that of the chemical shift to that of the higher value. And this is the problem is giving is that the different type of the complex that of the metals with the arenes or the metal carbonyls, the shifting of the carbon atoms in the 13th NMR is given here, and from this 13th problem, it has been shown that the MCH3 and MCO and M-benzene, that is the metal that of the alkyl, metal with carbonyl and metal with benzene, what is the 13th NMR shifting observed in that of the NMR spectroscopy. And if we see that from this observation, it has been seen that since the diamagnetic anisotropic effect is observed in case of the aromatic benzene, so the carbon falls in that of the paramagnetic zones, and hence it has higher chemical shift. But this shift is better in case of the carbonyl. We know that the carbon may resonate at 200 ppm, so its value is better compared to that of the aromatic carbons compared to that of the alkyl carbon. So if we see the shifting of the 13C value for the alkyl and aromatic carbon and the carbonyl, the alkyl carbon resonate at lower value and aromatic carbon resonate at the middle value, that is the between that of the 122 to 170 ppm, and the carbonyl carbon resonate at 200 ppm. and hence the order for the different type of the 13th NMR is that the metal carbonyl and then metal benzene and then metal CH3. Now this is the interesting problem that is related to that of the chemical shift, where the different type of the protons come in the different regions, and from this methanol, this is the one type of the carbonyl derivatives, and this carbonyl derivatives has the two methyl groups, and but they are connected at the same carbon atom, but they resonate at different value. This is due to that of the one methyl carbon resonate at 1.50 ppm and another methyl carbon resonate at 0.74 ppm, and this can be explained by the similar to that of the diamagnetic anisotropic effect. And according to the diamagnetic anisotropic effect, the methyl group resonate at the diamagnetic region, and the methyl proton resonate at the comparative to the paramagnetic region. So these two methyl groups resonate at different chemical shift value. If we see that of this brown hydrogen atom with that of the green hydrogen atom, the brown hydrogen atom resonate at lower value and the green hydrogen atom resonate at the higher value. This can also be explained by the diamagnetic anisotropic effect. According to the diamagnetic anisotropic effect, these hydrogens come into that of the diamagnetic zone and these hydrogen come to that of the paramagnetic zone. And if we see that of the some cyclohexene with that of the benzene, in case of the benzene, the ring current effect rises, and so the peripheral benzene protons resonate at the paramagnetic zones, and the paramagnetic zones means the protons fall to that of the higher chemical shift value. But in case of the ring current effect is absent in case of the cyclohexene, so the diamagnetic anisotropic effect is lower, and hence it resonates at lower value compared to that of the benzene. And if we compare to that of the two substrate, one is the alpha beta unsaturated ketones with the pyrene derivatives, and in case of the alpha beta unsaturated carbonyl compound cyclohexene, after resonance the positive charge is created beta to that of the carbonyl, so it has higher chemical shift value. And in case of the pyrene, the negative charge is created on the beta to that of the oxygen atom, and hence it shows the lower chemical shift value compared to the corresponding 6.35 value. And if we see that of the heterocyclic compounds, the chemical shift value it changes. The nitrogen ortho to that of the hydrogen atoms, the chemical shift value is 8.5, but the chemical shift value is lower for the green hydrogen atom, it will become 7.5. The resonance effect and the electronegative effect increase the chemical shift of the ortho to that of the nitrogen atom. In case of the isoquinolines, the similar results was observed. The hydrogen atom, black hydrogen atom resonate at 9.1 ppm, whereas the nitrogen atom ortho to it is resonate at 8.5 ppm. Here the aromatic rings ortho to hydrogen atoms resulted at that of the better diamagnetic anisotropic effect resulted in the protons are falling the D-link zones, and hence it resonate at higher value. Similarly, in case of paracyclophane derivatives, diamagnetic anisotropic effect resulted the black protons fall in that of the C-link regions and shows the chemical shift at the negative delta value. And this will be increases, and the peripheral next to that of the carbon atom, the chemical shift value is higher as it is fall in that of the C-link region. Next, we go to that of the problem for the type of the hydrogens and the carbon atom present in the molecules. In this case, the given problem is that there is the chlorine atoms, and this is the bicyclic compounds, and if we see that the sigma symmetry is going to that of the molecules, and since the sigma symmetry is going from the molecule, so the HI and HA is anisotropic, and HJ and HB is also anisotropic. Here Hg and Hd also anisotropic, HI, HC is also anisotropic. So if we go to that of the chemical shift signaling, and in case of the protons, here the HA and HI is come in the same region, that is the equivalent proton. HA is equal to HI, and HB is equal to HJ, and HD is equal to HG, and HC is equal to HH. and hence the signal is that the 1 and this becomes 2 and this becomes 3 and this becomes double, that is HF and HE, that is the 1, this becomes 2 and 3, this becomes, that is the sixth signal is coming from that of the signals, that is 1 and 2, 3, 4, 5 and 6. That is the sixth signal is coming here actually. Sixth signal means these protons are diastropic in nature. This proton is also diastropic in nature and this proton is also diastropic. That is the HA, HB is diastropic. HD and HC is also diastropic. HF and HE also diastropic. So diastropic protons are shown in the different signal, but the enantiopic proton, that is the HA and HI, gives the same signal. HB and HJ gives the same signal. HD and HG gives the same signal. HC and HH give the same signal, and hence the diastropic protons fall in the different chemical shift value, but the enantiopic proton go to that of the same chemical shift value. Hence the proton comes in the 6, but the carbon means here the carbon is that this carbon 1 and 8 carbon and 2 and 6 carbon, 1 and 8 carbon are enantiopic, so gives the same chemical shift. 2 and 6 carbon gives the same chemical shift, and 3 and 5 carbon gives the same chemical, and 4 carbon is the another chemical shift. Means 1, 2, 3, 4 and 5. This 7 carbon is the another chemical shift. That is 1, 6, 3, 4, 7 is the different carbon signal, and hence the option is that 6 and 5. And if we see on that of the problem, some interesting problem about that of the enantiopic and diastropic nature. Here also, if we see the look on that, HA and HC and HB and HD. HA and HC are the enantiopic, HB and HD also enantiopic. But here, HE and HF is the diastropic. So the signaling, if we go to that of the signaling, here 1, 2 and 3 signal is appear in case of that of the, this is the HA and HC go to the same signaling, and HB and HD gives that of the same signaling, that is the, this is the 1, 2 and 3, 4. That is the, this compound gives that of the 4 signal for the NMR spectroscopy. And if we go that of the cyclohexane molecule, they are axial and the equatorial protons, and this is the HA and HD also same chemical shift value, and HC and HB is also same chemical shift value, and HE and HF gives the different chemical shift value. And if we go to the HA and HE, here the axial and the equatorial proton gives that of the different chemical shift value. And if we go that of the NN dimethyl formamide, in case of the NN dimethyl formamide, if we resonate on the nitrogen lone pair, and this methyl and this methyl comes to that of the different chemical shift value, though the nitrogen atom contains the same methyl group on the nitrogen atom. And if we go to that of the alpha beta unsaturated cyclohexane derivative, go to the signaling on the spin splitting pattern, and if we see that of the H3 proton is splitted by H2 proton as well as H4 and H4 protons. That is H3 proton is splitted by H3 proton is splitted by H2 proton as a doublet, and again H4 proton is flat. H3 proton is then splitted by the H4 proton as well as the another H4 proton. So we get the doublet, another doublet, another doublet or doublet, and this is possible if we calculate the signaling on the spectra for the A, B, C, D proton. Here the AB and BC and CD, all the coupling constant is equal. So if we see on that of the CH2, there is the triplet. Another triplet is also arises by the C groups. So triplet, another triplet, and if we combine the intensity of this all signal, that is the triplet, another triplet, another triplet, and another triplet, and if we added it, we get that of the complete the intensity of the triplet of triplet of triplet of triplet. that is we get that of the overall intensity of this signal. This is actually this text is coming from that of the Pavier books, and if you also see the meta coupling with that of the ortho coupling. In case of if we see that of the ortho coupling, the coupling constant is greater, and if we see that of the meta coupling, the coupling constant is lower. And if we see that of this hydrogen is coupled with this hydrogen, and this hydrogen also further coupled with this hydrogen. That is there is a doublet, another doublet. This is the doublet of doublet. Again, this is the meta coupling. So there is a doublet and another doublet. So this is the doublet and another doublet. And we can also easily calculate the intensity of all these type of the proton signals. Now, the go to that of the NMR activity of the inactive NMR active nucleus or inactive nucleus determination. If we see that of the NMR active and inactive nucleus determination, which one is the NMR active and which one is the NMR inactive? And if we see that of the number of spin state formula, Ni plus 1. When I equal to 0, then the number of spin state equal to 1. So we get that of the only 1 or no signal. That is the when the combination of the 6 and 12, combination is 6 and 12, that is the even combination, leads to that of the no I value, and we get that only one state. So the excited state arises, excited state is not created, and hence the I equal to 0 NMR nucleus is NMR active, and those nucleus which has even combination with the mass number with that of the atomic number. This is the mass number with that of the atomic number even combination. So the I value is 0, and hence this becomes NMR inactive. And here the given protons, the net questions, given proton, that is the nitrogen 7, 14. They are the odd even combination. They are also odd combination. They are magnesium is the even combination. So this nucleus is NMR inactive nucleus. Now we go to that of the numerical problem. That is the molar ratio calculation. If we see that of the molar ratio calculation, the given problem is that in case of the acetone, the signal intensity is 8 millimeter for height, but in case of the chloroform, the signal intensity becomes 12 millimeter. And if we calculate the intensity for only one hydrogen, for chloroform, the only one hydrogen, so one hydrogen gives the intensity is 12 millimeter, but here the 6 hydrogen gives intensity 8 millimeter. So if we calculate it for the one hydrogen, the signal intensity becomes 3. So if we calculate the molar ratio with the chloroform with the acetone, there is a 12:3. So the molar ratio becomes 4:1. And hence the answer of this is 4, option 4. Now this video will become the next video, and this is the stereochemical related problem. And thank you for my students of the YouTube. Thank you.